What are the special solutions to r of x equals 0, y transpose r equals 0 for this r? Okay, let's start with the first r. Okay, so the first thing to notice is we have to solve rx equals 0, and since this is a 3 by 4, column x has to be 4, right? It has to be 4 by 1. There has to be 4 unknowns, so that means x has to be x1, x2, x3, x4, because the number of columns on the first matrix has to equal the number of rows on the matrix that multiplies it to the right. Okay, so now, having said that, now we have to solve the following equation. We have to solve 1, 0, 2, 3, 0, 1, 4, 5, 0, 0, 0, 0 times x1, x2, x3, x4, and of course that has to equal 0, 0, 0. 0, 0, 0, because you're gonna get this is a 3 by 4, 4 by 1, you're gonna get a 3 by 1. You're gonna get a 3 by 1. Okay, well, now let's take a look at this matrix here. Notice that this is a pivot on the first column, and this is another pivot on the second column. That means, so we have two pivots. Below the first pivot already 0, below the second pivot and above it already zeros. Now if you go to the third column is just a linear combination of the first two columns, because you can get the third column from 2 times the first column plus 4 times the second column. So this is a free column. It has free variables. It doesn't count. And the same exact argument can be made on the fourth column. So there's no pivots on the third column, and there will be no pivots on the fourth column, because again the fourth column is 3 times the first column plus 5 times the second column. Okay, so that means we have two free variables here. That means we have two free variables. The free variables, since column number 3 and column number 4 don't have pivots, the free variables will be x3 and x4, corresponding to the third column and the fourth column. So basically we have two pivots, so r is equal to for this matrix. Okay, now how do we solve it? Now, since those are free variables, what we could do is we can take them to be anything, right? Special solutions. So that means they could be anything. So I could call them so I could set x3 equals 0. I could set x3 equals 0 since it's a free variable. So this tells me that I could set x3 equals 0 and x4 equal 1. And then I could go and find x1 and x2 from the equations. I know from the first equation, right? x1, let's write the equations. So now from the matrix, you could reduce it further, but this is enough. So x1 plus 0x2 plus 2x3, so plus 0 because x3 is 0, plus 3x4, 3 times 1 equals 0. Yeah? which would make x1 to equal -3. And then I could go to the second equation. I basically have two equations. So 0x1, so that's 0, plus x2, which I'm trying to find, plus 4x3, which is 0, plus 5x4, plus 5 equals 0, and that would give me x2 equal -5. Okay, so that means one of the solutions, S1, is x1, x2, x3, x4. So my first one, let me write it as x1, right? So my first solution, x1, is I shouldn't call it x1 because I called that x1. Let me call it solution 1. Solution 1 will be -3 -5 0 1 times any linear multiple of this will be in the same exact space. So times, let's say, C1. So this is my special solution 1, right? Because I could have made x4 5 instead of 1. It doesn't have to be 1. You're paying attention? Okay, now I could, so now remember, this came from me letting x3 equal 0, x4 equal 1. Now I flip it around. I let x4 equal 1, x3 equal 1, and x4 equal 0. This will give me my second free solution. So now I would switch them around. So x3 equal 1 and x4 equals 0. And again, I go back to the equations to get my x1 and x2. Those are the variables, right? These are the free variables here. Okay, so that means if I go to equation number 1, x1 x1 plus 0x2, which is 0, plus 2x3 plus 2 plus 3x4, which is 0, equals 0. So that makes x1 equal -2. And I go to the second equation, 0x1, which is 0, 1x2, which I don't know, 4x3 plus 4, and 5 times 0 is 0, so this is 0, which makes x2 equal -4. So that means my S2, my second solution, will be -2 -4 1 0 and any combination thereof, so times some C2, whatever that C2 is. Okay, so that means my final answer will be the linear combination of all these special solutions. So my x1, x2, x3, x4, this is, by the way, an exam type question. Okay, so this is equal, will be C1 times my first solution, -3 -5 0 1, plus C2 times -2 -4 1 0. Okay, these are the special solutions. You asked me about the null space, so this is an opportunity for me to tell you this: the special solutions that you got from setting the matrix A times the column vector x equals 0, the special solutions that you got from that, they form the null space. They form the null space of the matrix. Right. So this is how you do this from this is how you find the special solutions for Rx equals 0. Now the second part, so this was the first part. The second part is y transpose R equals 0. So I'm still working on the first R, the one on the left. So let's move on to the second one. So this is y transpose times R equals 0. Now remember, R is 1 0 2 3 0 1 4 5 and 0 0 0 0. Okay, so this is a what? This is a 3 by 4 matrix, which means y transpose, to be able to multiply this, y transpose have to be a 3, has to be a 1 by 3. It has to have 3, so there has to be 1 row 3 columns. So that means I'm gonna get y1 y2 y3. This is my y transpose. And now, of course, when I multiply a 1 by 3 times a 3 by 4, I'm gonna get a 1 by 4. So 1 row 4 columns. Yeah, so which will be 1 row 4 columns will be with 1 by 4. So this will be 0 0 sorry, 0 0 0 0. Okay, well, let's write this as equations. What are these equations? Row times column, this times this. So we get y1 immediately equals 0, right? Right away, y1 equals 0. The second equation will also get you, oops, sorry, this is 1 second, this is y2, not y1. This is y2. Okay, so the second equation will also get you 0 times y1 plus y2 times 1, which is y2, plus 0 times y3 equals 0. So y1 equals 0, y2 equals 0. And now if I go to the third equation, I have 2y1 plus 4y2 plus 0y3 equals 0. Yeah. And the fourth equation is 3y1 plus 5y2 plus 0y3 equals 0. Right? So y1 and y2 equals 0, so that means y3 is a free variable in this case, because y3 does not appear in the equation. So y3 is a free variable. If y3 is a free variable, then you could set y3 to equal 1. Right? So what would you get then? Then you would get y1. Well, we already know that those for sure, the first two are zeros, no question. So that tells us that y1, y2, y3 transpose or whatever, doesn't matter, equal 0 0 1, or any linear combination of them times C1. Okay, so that means this will be the special solution for y transpose R equals 0. Some C1 times 0 0 1, and this is also the null space, which is a plane. 0 0 1, it's the xy plane. So this is the answer. There's only one special solution, C1001, because there was one free variable in this. You get the idea? You wanna try the second matrix? Okay, now moving on to the second matrix, which is R. So I'm gonna do the second part of the question, where R now is 0, 1, 2, 0, 0, 0, 0, 0, 0. Okay, and we need to find solutions in the form Rx equals 0. So this is gonna be similar to the first question, where x will equal to x1, x2, x3. So column vector 3 by 1. Okay, so that means we have 0. Change the color here. That means we have 0, 1, 2, 0, 0, 0, 0, 0, 0, x1, x2, x3, equals 0, 0, 0. Okay, now notice that the first pivot is contained on the second column, so this is a column that contains a pivot, and there's no pivots here, so this is a free variable, so this is a free column here, so free, and this here is also free because this is just twice column number 2. If you multiply column number 2 by 2, you get column number 3. So this is 2 column 2, so that means it's also free, which means I only have one pivot here, which means I have 2 free variables. So the free variables are the variables represented by the free columns. In this case will be x1, x3. And so to find the special solutions, I will let x1 equal 0 first, x3 or x1 equal 1, x3 equals 0, and I will go on to find what x2 is from the equation in the matrix. So my equation will be 0x1, I'm multiplying row times column equal this. So 0x1 will be 0 plus x2, so x2 plus 2x3 plus 0, because x3 is 0, equals 0. So that makes x2 equals 0. So my first solution, s1, will equal, so here I'm working on s1, will equal 1, 0, 0 times, and the linear combination of this times any other scalar multiple of this will be the special solution. And now next, to go for s2, that working out, Ben, the second one? To go for s2, now I would switch around, so I would say x1 equals 0 and x3, the free variables, I would give specific, so the identity matrix solution to the free variables 0, 1, and I would go on from the matrix to find what x2 is. You understood what I did on the first part? So this is 0x1, which is 0, plus x2 plus x2 plus 2, this is here x3, plus 2x3, and x3 is 1, so plus 2 equals 0, so that means x2 equal 2. So that means my second solution, s2, will be some multiple of 0 to 1. 1 second, this is this is plus 2, minus 2, so this will make it minus 2. So therefore my special solution is here is C1 1 0 0 plus C2 0 minus 2 1. So the special solutions are 1 0 0 0 minus 2 1. What do you say, Ben? Okay, and for the last part, which is y transpose r, so this is going to be similar to the first matrix. So I have y1 y2 y3 times my matrix 0 1 2 0 0 0 0 0 0, and this has to equal 0 0 0 0 0. I don't have space, so let me just write it as like this: 0 0 0 transpose. Okay, and so if I do the equations here, I will get the first equation, y1. The first equation isn't gonna give me anything because 0, actually it does. 0 y1 y2, so this is row times column, so 0 equals 0. The first equation will give me 0 equals 0, and then this is true, but not useful. u1 y1 plus 0 y2 plus 0 y3 equals 0, so y1 equals 0, and then 2y1 plus 0 y2 plus 0 y3 equals 0. Same answer, y1 equals 0. So that means I have two free variables. Since I have a definite answer on this, I have two free variables. My free variables are, so free variables are y2 and y3. y2 and y3. Okay, so why don't I call y2 to be 1? That's for S1. And y3 to be 0. Same strategy I used. And in that case, I would have my S1 to be 0 1 0, or for S2, or any scalar multiple of that, C1. And my S2 would be, I would call y2 to be 0 and y3 to be 1, and my S2 will be y1 0 0 1 times any scalar multiple of this. So therefore, if I want my solution in general, y1 y2 y3, this will equal C1 0 1 0 plus C2 0 0 1. And my special solutions are these two solutions here. So special solutions zero one zero 0 0 1. How are we doing, Ben?